Now that we know how to measure DC voltage and AC voltage as well, let's take a look at another very important test that we can make with our meter. There are certain types of power supply failures that allow a small amount of alternating current to ride on top of the direct current. This condition is known as power supply hum or power supply ripple, and can generally be attributed to a bad filter capacitor. The filter capacitor is very important for a power supply because it assures that the power supply voltage remains absolutely pure and constant. When the power supply has excessive ripple in it, the computer may malfunction or it may not work at all. So let's take a look at what we'll see when we have a bad filter capacitor in a power supply. As long as the 5-volt supply remains constant, the computer works normally and displays the picture you see here. But if the capacitor fails, hum bars occur. These horizontal blue bars are known as hum bars and are a visual indication of a bad filter capacitor. When the capacitor fails, the power supply does not remain constant. That is, the voltage is constantly changing. When we measure the DC voltage of the power supply with our meter set on the 20-volt range, the supply reads 4.58 volts. That's because the meter averages the times when the voltage is up at 5 volts with the times that the voltage is allowed to drop lower due to the bad filter capacitor. Well, we can easily determine if this problem is low voltage or ripple by switching our meter to read AC volts. When we switch the meter to read AC volts and check the voltage again, we see that the meter reads 0.6 of a volt of AC ripple riding on top of the DC. It doesn't matter if the power supply is in a video game or a pinball machine like this. Ripple will still test the same way. When the voltage reads too low on your meter, switch your meter to read AC volts and look for that AC ripple. In this case, 1.6 volts of AC ripple riding on top of the 5-volt supply means that we have a ripple problem here, usually caused by a bad capacitor. In this case, though, we can trace the problem to a broken wire. The broken wire disconnects the capacitor and allows excessive ripple into the supply.